Okay, so we're going to do 71, 75, 85, and 65 from P6. So I'll start with 65. Wrong page here. All right, 65. 1 over x plus 1 all over 1 over x squared minus 2x minus 3 plus 1 over x minus 3. All right, so if you look at if we're clearing fractions, you're looking for the mini denominators within, and we have 3 of them. The one thing I would say on this one is let's factor this one first so as to avoid overdoing it a bit. So this factors into x minus 3, x plus 1, which means if this is a denominator, this is a denominator, and this is a denominator, the least common denominator of all of those would be an x minus 3, x plus 1. So we multiply by that on the top, and we multiply by that on the bottom. That's us multiplying by 1 creatively so as to change the appearance but not change the value. So when I just do this single multiplication here, the x plus 1's cancel. That's clearing that first fraction in the numerator. So your numerator is just x minus 3. And on the bottom, we've got to distribute, right? We've got a term plus a term. So when we distribute to the first term, these both cancel with there and clear, leaving just a 1. And when we do this distribution, the x minus 3 cancels with that, leaving just 1 times x plus 1. Got our plus sign in there. And then, do you need the 1 here? Not really, but I'll put it just to be consistent, because if it was any other number, we would. And there we are. We've cleared the complexity. And then we're just cleaning this up. So we have x minus 3 up top, and then on the bottom, x plus 1 is x plus 2. And there's your final answer. X cannot equal anything that was ever in any denominator at all. -1 or 3. And then in the final answer, x plus 2 tells us that -2 is not possible either. So 71 gets a little bit yuckier looking with the radicals, but actually this one might end up cleaning up more easily. All over. Also on your homeworks, don't be afraid to use space, because if you try to jam this in, that is not going to go well for you. All right, so there's only one mini fraction within the larger fraction, and that's this one right here. So the least common denominator here is just what that is. So on the numerator, on the bigger overall numerator, I'm multiplying by x squared plus 2, and again, I'm going to have to distribute that. And on the denominator, I'm going to have to multiply by that. Now, I'm only going to distribute on the top. That's going to cancel this, leaving us with just x squared, fraction cleared. And this is a beautiful thing, because the radical and the radical will become just x squared plus 2. You do have a minus sign there, though, and you're subtracting the product, which ends up being a binomial, x squared plus 2. This times this gives you a binomial product. So keep that subtraction sign there. And then on the bottom, there's no distributing. This times a radical is just this times a radical. And then up top, we'll clean it up. Distribute your minus sign. So x squared minus x squared will be gone, and it's just going to be a -2 over x squared root x squared plus 2. Now, x cannot equal, let's see, nothing would make this 0, because this would have to be -2, and it's a something squared, so that'll never be 0. This denominator could be 0, though, so we have to say x cannot equal 0, because that, if x was 0, that would make us with an undefined. So -2 over, beautiful. Okay? 75, I think I'm out of paper here. 75 is, okay, square root of x plus 5 minus root x all over 5. And this is rationalizing like we did the other day. But it may seem weird now, but definitely in calculus, we'll need to rationalize the numerator in different moments. So rationalizing just means get rid of the radicals there, rationalizing the numerator. So just like we did the other day with the radical chapter, if your radical is a part of a binomial, you multiply by the conjugate, root x plus 5 plus root x on both the top and the bottom. That's our creative way of multiplying by 1. So we're going to change the appearance, but we're not going to change the value. So when we FOIL up top, root x plus 5 times root x plus 5 is x plus 5. The beauty of conjugates is that this outer and this inner product, one will be positive, one will be negative. They're going to cancel. And then the negative root x times the positive root x is negative x. On the denominator, I'm not going to distribute. This is not where I'm trying to get rid of radicals. So it's going to be better for you. Only distribute where you're actually trying to get rid of the radicals, which was the numerator, since we are rationalizing the numerator. On the bottom, I advise you, and you'll see why, maybe not all the time, but most of the time it'll help you, because then you'll see some more simplification, and it is going to help us here. Because up top, your x minus x cancels, so you're just left with 5 over 5 times this whole thing. If I had distributed the 5, I would have to refactor out the 5 and see that this 5 over this 5 cancels. So we have 1 over root x plus 5 plus root x, and that's our final answer for 75. And lastly, 85. Ooh, this is a hefty one. Perform the operation and simplify. So 1 over a cubed minus b cubed times ac plus ad minus bc minus bd all over 1 minus c minus d on the numerator over a squared plus ab plus b squared. Okay. Fun. Okay. First thing I'm going to say is we want to start factoring, because anything that we can cancel right out of the gate, we want to do that. So on this denominator, difference of perfect cubes, a minus b, a squared plus ab plus b squared. The more fluent you get with that soap, the better. Times. Up here, I'm going to say it's a grouping, 2 by 2. Pull out an A, you're left with C plus D. Pull out a negative B, you're left with a C plus D. So that C plus D is going to be one factor, and A minus B is going to be the other, over 1. Minus C minus D over this factors into, oh, does it? Oh, nope, I don't think it does. As a matter of fact, it does not. A squared plus AB plus B squared. Okay, this makes me a little nervous. I'm just going to go ahead and do that for safety reasons, because we are going to have to distribute that minus through the numerator, I would bet. So this A minus B and this A minus B cancel because of the multiplication symbol. So we just have this fraction when you finally multiply it, C plus D over A squared plus AB plus B squared minus C minus D over A squared plus AB plus B squared. Now, typically, you'd have to get a common denominator, but lucky for us, they're already common. So when you do your subtraction, we keep the same denominator, right? When you subtract fractions, 3/5 minus 1/5 is 2/5. We keep the same denominator and just do the subtraction within the numerator. So we're going to C minus C, gone. D minus a negative D is going to be D plus D is going to be 2D. And there's your final answer for 85. We just check it, make sure I didn't do anything silly, and we are good.